Welcome, everybody. Thank you for joining us today, especially those of you in the middle of a heat wave. My name is Tess Mostolis. I am one of Expana's editors, and I specialize in fruit, nuts, herbs, and spices. At Expana, we bring you over 200 years of experience providing you with critical market intelligence to feed the world with the data it needs. This includes over 37,000 price series and 2,000 price forecasts. So our audience can have a full visibility of the supply chains and tools to manage volatility. Today, we have put together a fantastic duo for you with our two Expana experts to dig deep into how this year's El Niño could affect agricultural commodities. This webinar ought to provide you with a comprehensive understanding on how these developing weather patterns could disrupt harvests, production, and supply chains. We will take a look at the main forecast models, explore how strong this event could become and what that means. We will also cover previous El Niño years and their effects across the world and what we can learn from those. To guide us into all of this, we have James Tyler, weather and crop researcher at Expana, who manages and produces weather and crop data and insights. With a background in geographical information systems, he will break down the core climate outlook, latest sea surface temperature data, and secondary weather impacts. And also, Philip Manamel, Director of Fundamental Analysis, who has 2 decades of experience in the softs markets and manages the fundamentals team covering softs, grain, oilseeds at Expana. Today, he will take us around the world where historically weather events have disrupted agriculture. This is our legal disclaimer, which you can look in detail once you receive the slides later on. We will also have a Q&A at the end, so please post your questions in the chat and we will try to get to as many as possible. James, the floor is yours.
Thank you very much. Hello, everyone. I hope you're keeping cool if you're in Europe, especially as we're going to dive into such a hot topic, El Niño. What exactly is an El Niño? To tell you what an El Niño is, I will tell you what an El Niño is not, as in what is the normal Pacific conditions. So when there's not an El Niño, when it's ENSO neutral, as it's known, warmer water pulls up on the west of the Pacific Ocean, and this leads to a rising column of moist air that leads to higher rainfall in the west side, in Southeast Asia. And as that air travels across the Pacific Ocean, it leads to less rainfall in South America. This is the normal conditions. When there's an El Niño, it's a reverse, not a reverse of this, but it's all the warmer water in the Pacific Ocean pulls up on the east side of the Pacific. And that column of rising moist air follows suit. It follows the warmer water across the Pacific Ocean, which means that rainfall that was falling in normal conditions on Southeast Asia gets pulled more away, leading to lower than average rainfall and more rainfall in South America compared to usual. So what this means is the Pacific weather patterns are altered as the circulation is disrupted, but also beyond that, global weather patterns are disrupted because this alters the weather circulations of other weather circulations around the world. And what this means is that the shifting rainfall and temperature due to the El Niño can influence the typical growing conditions for crops, which can lead to negative, reducing yields, possibly increasing yields in some cases, which can of course affect supplies, as well as supply chains, logistics, and ultimately prices. So now I hope you know roughly what an El Niño is. I want to tell you what it isn't, because there's a lot of information about El Niños. So I think it's important to know what the El Niño is not. And that is the most important thing to remember, is the El Niño is not a guarantee of certain weather events. It is one factor among many that can encourage certain weather events to happen. If you take Southeast Asia, for example, El Niño is one factor in this scale that I've displayed that could encourage it to become dry. However, if there is enough other weather factors or weight on this scale in the other direction, then it can lead to a wetter than average, even if an El Niño is going on, or neutral. So that's one major thing to remember. It's also not an unnatural phenomenon. This has been going on basically since the Pacific Ocean has existed, and it does not affect all countries simultaneously. Whether it depends on the geography and also the season, when the country is impacted by Niño or could be impacted by El Niño. It does not also only lead to negatives. You can have a higher amount of rainfall due to the El Niño, which of course can be negative for crops, but also it can reduce the drought risk. And if an area is warmer than average, it can reduce frost risk. So it's not only negatives. And the last one is a debated statement that climate change is not making them stronger or more frequent. This is debated, as I say. The long-term scientific opinion is that it's not making them stronger or more frequent, but this is especially recently contested. What's less debated and what's more agreed upon is that the impacts of El Niño are more amplified by the changing climate. So they can go hand in hand together to make more impactful weather. So what's going on now, right now, in the Pacific Ocean? If you look at the maps on the left, these are sea surface temperature anomaly maps of the Pacific Ocean. And if you look in the green box, the black box, which is the Niño 3.4 region, that's just what we use to measure El Niños and their strengths, and La Niñas, which is the opposite of El Niño. You can see at the start of the year, it's blue, which is below average sea surface temperature. But it transitions up till May into red, which is warmer than average. And you can see where we are now in May, the Niño 3.4 region is warmer than average. And really clearly, you can see all that warmer water pooling up on the east of the Pacific, just like the diagram I just displayed a few slides ago. So these are really typical El Niño sea conditions. Does that mean the El Niño has started based on this? Broadly speaking, yes, it has started. NOAA, which is the US Weather Administration, has announced that the El Niño has begun, based specifically on the atmospheric conditions. So the atmospheric circulation I showed you at the start has been disrupted, indicative of El Niño occurring. I stress the word indicative because using the official thresholds by NOAA, which is the Relative Oceanic Niño Index, RONI, the threshold has not been reached yet. If you look at the top chart on the right, this is the RONI relative data, and the darker purple line is the 3-month rolling average, which is what what is used. If it passes over the threshold, then an El Niño that's declared or reached. But as you can see, the weekly value, which is the lighter purple, pink line, has already crossed the El Niño threshold, and is even in moderate region. So whilst it hasn't across the official human-made index, El Niño conditions are certainly present. Now I've added the chart at the bottom, which is the Oceanic Niño Index, so without the relative. And I've added this because it's the old method that NOAA used to use, and they replaced it in February with the relative index. Now, some of you might be more used to using that because that's what's been used for the last 30 years by NOAA and by other forecasting, other papers and journalists and such. So I've added that in case you're more used to that. And I've added it for the fact that if you were to refer to that, you can see the weekly values have even crossed the strong threshold. So what I'm saying is the El Nino has started already. But where's it going to go? How strong is it going to get? What does that mean? Well, I should tell you. And I appreciate there's a lot on this chart, but I'll guide you through it. On the left side, you have the black line, the solid black line, which is the monthly values. The red line is the 3 monthly rolling average values, same as the previous charts I just shown for the relative data. On the right side, you can see all these dotted lines, which are different forecasting centers. And I want you to pay attention to the black dashed line, which is an average of those centers, and the red dashed line, which is a 3-month rolling average of that average. So it aligns much better to the relative oceanic Neo index that NOAA uses, the red dashed line. So focus on the red dashed line, and you can see that the red dashed line exceeds a very strong El Nino towards the end of the year. September. And it reaches 2.6 degrees Celsius above historical average. You may be asking, well, it hits 2.6, it goes over 2.5. Some of those individual forecasts exceed 3 degrees. You may ask, what's the term for that? What's NOAA's official term for those strengths? There isn't one currently. But I want to stress that that doesn't mean that they hit very strong El Nino and they're just as strong as any very strong El Nino. They can get stronger than that. And this is going to be, well, based on the forecast, it's going to be stronger than an El Nino that just surpasses the very strong threshold. And I want to point out that a reason that we use lots of different forecasting centers and average them together, rather than just using one, is because then we can see the confidence between the forecasts, how much they agree with each other. In general, these forecasts agree with each other in the terms of the direction. There's some exceptions. The lowest one there, the blue line, Germany, where that only goes up to strong, possibly only moderate El Nino. But most of the forecasting centers are going up above very strong. So what does that mean? What does a very strong El Nino mean? Basically, a very strong El Nino, well, the stronger an El Nino is, the more likely that weather patterns that are typical of an El Nino, which Philip will show you soon, become more likely to materialize. So that extreme weather is more likely to happen. You could think of it, if you imagine the scales from earlier, you could imagine that the stronger it is, the heavier that El Nino is on the scale, which in turn can mean that supply chains are more likely to be impacted the stronger an El Nino is, at least somewhere in the world. So how does this compare to some of the strongest El Ninos? Well, this is the same chart. When it comes to the red line, the dashed line is still the same red line as I showed you before. I've added some of the previous strongest El Ninos based off the relative oceanic Nino index. And what you can see is that it would exceed the strongest El Nino on record since the 1950s, which is as far back as the reliable record goes, which was 1982, 1983. As well as the last very strong El Nino, which was the second strongest, 2015, 2016. And it, of course, exceeds the last El Nino, which reached strong level and was 2023, 24. It doesn't exceed it by margins, but as I show, it has the potential, based on this forecast, to be the strongest El Nino on this record. If we want to take it another look at a different angle, we can take the CPC, which is the NOAA's Climate Prediction Center's probability forecast. So this is the same forecast that NOAA uses, but it is adjusted into probabilities. What you can see is that throughout the rest of this year, there is a very low chance that it will go back to neutral conditions and a very high chance that it will be a continuing El Nino. So El Nino is here and very likely to stay for the remainder of the year. And in terms of strength, this agrees with the previous forecasts. If you look at the October, November, December, or the November, December, January, towards the end of the chart, you can see there's a 60% chance of a very strong El Nino forming. So there is a good likelihood that a very strong El Nino could form. But what does this mean for you? I will pass over to Philip.
Thanks, James. So given that the forecast is for a very strong El Nino to develop by the end of the year, what we've done is to look at events in the past 5 decades where we've had very strong El Ninos. It's worth bearing in mind that not only is the intensity of the El Nino important, but what's also important is when it develops and when it hits that peak intensity. So a lot of the examples that I will show you going forward will cover sort of the 97, 98, and 2015, 16, which I've used as primary analog years for very strong El Ninos, and 2009, 10, and 23, 24 as your strong El Ninos. But just before we get into the impacts of these El Ninos, what we have done is looked at the weekly evolution of the sea surface temperature anomalies and compared them with the historically strong events. What you can see on this chart quite clearly is the similarity between the 97, 98 El Nino and how that developed versus this year thus far. So I spoke about the 2 windows that we look at. So the first window that is critical is the June-August window, your Northern Hemisphere summer. By and large, during this period, you have drier than normal weather across the globe. So it's worth bearing in mind that in the Northern Hemisphere, this is, especially in the tropics, this is the wet season. And in Southeast Asia in particular, and Australia, you get drier than normal conditions. You have something similar in Central America. In the Southern Hemisphere, which is primarily Indonesia, Australia, you have a very harsh dry season. And it's worth noting that in Brazil or Latin America, you have warmer than normal weather, which reduces the risk of frost, which sometimes hits the south of the country. Now, the other window is the Southern Hemisphere summer or your Northern Hemisphere winter. Now, the impacts during this period are slightly different. So what you tend to see is Southeast Asia and Australia tend to remain very dry, but the Pacific coast of Latin America, so around Ecuador, parts of Colombia, Peru, are wetter than normal. The south of Brazil can be wetter than normal during what is the wet season in South America. So what we will show is how the time of year becomes quite an important aspect when thinking about these impacts. So given my background in the softs, I have to put my hand up and admit that a lot of the examples that you will see would be focused on these commodities, but also because these are the commodities where we've got field teams on the ground in a lot of these countries. So we'll start in the east first in Indonesia. Now, given the size of the country and it being an archipelago of over 2,600 or 2,700 islands, we've focused our rainfall charts on areas where the primary coffee growing areas, as opposed to taking the whole country and averaging the rainfall out there. What you tend to see here during very strong El Ninos, and this is apparent in both the 97, 98 chart and the 15, 16 chart on the right, is that during the peak of the dry season, so that's between June, July, August, you have very dry conditions. It also increases the risk in Indonesia of forest fires. And I quite clearly remember living out in Singapore during the 15, 16 El Nino, where most of Southeast Asia was enveloped in haze for months on end. So that's the negative aspect of what happens in Indonesia. However, there could also be a positive aspect to this, which is during the peak of the wet season, so that's at the turn of the year, you get lower than normal rainfall. And for regions that are receiving, say, 400 or 500 millimeters of rainfall per month on average, slightly lower than normal rainfall can benefit crops. So what happens when it's not as strong? What we see is the same patterns prevail, but they may not be as pronounced. They may not be as pronounced. My apologies for the slides, but they may not be as pronounced as during very strong events. So now we've seen what happens in the Southern Hemisphere. Now, if we move to Vietnam, what we see is that during the peak of the wet season, you don't have too much of a concern over the amount of rainfall during El Ninos, even during strong El Ninos. But what becomes apparent is the risk to the end of the wet season and the start of the following wet season. And this could have quite a material impact depending on if it's an annual crop like coffee, depending on where you are in that cycle, or if it's a row crop, when that's planted and that sort of impact that it could have then. When the El Ninos are not as strong, or when it's not a very strong El Nino, but a strong El Nino instead, we don't see as pronounced an impact on rainfall in Vietnam at that point. Now, moving further east to India, where there is currently a lot of talk about the ongoing monsoon in the country, we've, as opposed to covering the whole country again, we focused on central India, which is quite important, you know, for sugarcane, for cotton, for soybean. So what we see is the relationship between El Ninos, the strength of the El Nino, and rainfall is not as clear. Now, I'm not saying that the current El Nino is not going to impact the monsoon, because quite clearly there is a problem with what's materialized so far. But there are also other factors like the Indian Ocean Dipole, like the Madden-Julian Oscillation, which come into play, which could also switch what happens during strong El Ninos. So similarly, when you look at other years where the El Ninos are not as strong as the two extreme events that we highlighted, we do see that you have months where you've got good rainfall, you've got months where you have poorer than normal rainfall. So drawing a conclusion that the El Nino itself is impacting the monsoon rainfall in central India remains to be seen. The next example that I'd like to highlight, and another one that's sort of spoken about quite a lot in the soft commodity space, is West Africa. There is a lot of talk that the El Nino would have quite a material impact on weather or rainfall in West Africa. Now, this 1982-83 was a little bit before my time, but I have heard anecdotes of severe bushfires affecting Ghana. Whereas if you look at the other very strong El Nino more recently, in 2015-16, we have seen that there can be quite a pronounced impact. So sometimes in West Africa, it's the strength of the El Nino itself and the timing of the El Nino which could have an impact. But if you look at it across all El Ninos, we don't see as pronounced an impact on the rainfall in West Africa. So this just is a couple of pictures that our field teams had from the 15-16 El Nino in Côte d'Ivoire and the impact it had on Côte d'Ivoire. So, like I was saying a little earlier, if you look at the two strong El Ninos, we're not seeing a negative impact of below normal rainfall in Côte d'Ivoire in those 2 years. Whereas on the stronger El Ninos, we did see a little bit of lower than normal rainfall during the mini dry season, which is sort of June to August. But more critically, at the turn of the year when you got the harmattan, that was pronounced in some instances, but not all. moving further east, we looked at rainfall across Central America. Now, I've used Honduras as an example, but we'd also looked at Mexico, we'd looked at Guatemala, and by and large, the impacts were broadly the same, where what we saw is a couple of months, so particularly July and August rainfall tends to be lower than normal during very, very strong El Niños. Whereas during a strong El Nino, but not a very strong El Nino, that impact is maybe a little less pronounced than it would be otherwise. And lastly, I think the most important of the lot is the Pacific coast of Latin America, where we've looked at Ecuador, in particular, given its growing importance to the cocoa market today. And the one thing that is very clear is that during very strong El Ninos, you have very, very heavy rainfall in the sort of in the summer months, my apologies, which are already months where, on average, there are a lot of places receiving 600-700 millimeters of rainfall. And during these strong events, you get another 200 millimeters or so, which has the potential to be hugely detrimental to crops at that point in the year. So what happens when you have a strong event? In most instances, during a strong event, you see a similar impact on the rainfall at that point in the year. So now I've sort of taken you across the world, covering the precipitation impacts on various key producing origins. But those are not the only impacts that we see. So I'll now give it back to James to take you through some of the other impacts that we could see during an El Nino.
Thank you, Philip. Oh, there we are. So yes, other global consequences of El Nino, almost indirect secondary consequences, you could say. I shan't talk through all of these, and these aren't all of the effects, of course, but I'll point out some. So storms, specifically hurricanes in the Atlantic Ocean. The El Nino typically leads to fewer hurricanes forming in the Atlantic Ocean. NOAA has already forecasted this for this year. And what this could mean is a reduce in pressure on certain crops that are usually impacted by hurricanes in the US. Things like cotton, some of the grains, peanuts and pecans and citrus and some tropical fruits. But on the other side of the continent, on the Pacific side, there could be increase in hurricanes, potentially affecting Mexican produce, such as citrus, tropical fruits, certain vegetables. There could also be some threats to California in the US. It's not common for hurricanes to reach that high, but they can, and it's more likely during a El Nino year. If you go further south down to the Panama Canal, that is also at risk of disruption, because if you don't know, the Panama Canal relies on fresh water, and when there is an El Nino, it can induce drought, which can lead to restrictions being made to preserve the water in the canal that fuels the canal. And this is exactly what happened during the last El Nino, 2023 to 24. There was a drought induced by El Nino and led to low water reserves, and there had to be restrictions introduced on the number of ships per day and the amount that they could carry, leading to long waiting times and delays and disruption. Further south, again, we go to the coast of Peru, where there could be fewer fish catches, most famously anchovies, of which Peru is the major exporter of. Those fish typically, because of all that warm water that's shifted over, may migrate to cooler waters beyond the typical fishing areas. They can also reduce populations or affect them in negative ways that can lead them to lower catch. And that can happen in other parts of the world, but it's also famous for anchovies in Peru. If we jump over to the other side of the world, so along Australia and Southeast Asia, there could be an increase in wildfire risk due to potential dry conditions. But also in Australia, there could be fewer cyclones during their season. In Southeast Asia, when it comes to typhoons, it's a bit more nuanced, but essentially the typhoon risk in South China Sea generally reduces, and the risk further north to countries like Japan and China and South Korea could be increased. And it's simply because the warmer waters that produce these typhoons have moved further away from the land, and these typhoons can still form, they just form further away, travel west, as a typhoon would normally do, and it has more opportunity to curve northwards, as it's also encouraged to do, meaning a larger threat to countries further north. Now, there is one thing, big global consequence that hasn't been mentioned here, and that is an increase in global temperatures. So during an El Niño event, the global baseline temperature generally rises, and this is usually the case for the second year. So this was more likely to affect temperatures, global temperatures in 2027. This is on top of the long-term climate warming. And if you look at the chart on the right, which is global temperature anomaly since the 1980s, you can see, of course, I'm sure many of you see it before, every year the temperature, every decade getting higher and higher due to the climate warming. But also you'll see that a lot of the warmest years, including the last warmest year, 2024, was El Niño years, at least moderate El Niños. In fact, if you were to slice this up into decades, every decade's warmest year would be an El Niño year. Does this mean that 2027 could be the warmest year on record? Potentially. Like I've pointed out, certain weather events aren't guaranteed, but next year has the potential to be. According to the World Meteorological Organization, they've recently said that there is an 86% chance that one of the years in the next 5 years could reach the new temperature record globally. That year could be 2027, and considering that a very strong El Niño is forecasted, possibly the strongest on modern record, 2027 could be the strongest year. Could be the warmest year on record. And that is my final note. I believe we're going into questions.
Well, thank you so much, James and Philip, for those wonderful presentations. We do have received quite a few questions from the audience, so let's try to get to as many as possible. Let's see. Philip, the first one is coming your way. These slides compare the current event to 1997, 1998, to 2015, 2016, and also to 2023 and 2024. Which one of those historical analog would you think is the most relevant to what we're seeing now, and why?
I think, as I mentioned during the presentation, for me, the closest analog at the moment would be the 97-98 El Nino, simply because of the way it's developing. If you look at the weekly temperatures, the way the weekly temperatures are evolving is very similar to the 97-98 El Nino. Having said that, I think it's also important to note that 2015-16, what we call it the 2015-16 El Nino, that was an El Nino that started towards the end of 2014. And it was unusual in the sense that it was prevalent for almost 18 months, whereas most El Ninos generally have a 12-month cycle.
Thank you. James, this one is for you. How much weight should we put on the discrepancy regarding a potential El Niño on the different agencies when assessing the current event?
Well, like with any forecast, it's worth being cautious. And I think, as I said, having multiple forecasting centers gives us a bit more confidence. But as you saw, there is a variation between them. And this is, there is different forecasting methods. So I think from that direction, considering they're all going in the same direction, there's a bit less of uncertainty. There is reason to be a little bit more cautious this time of year. During the spring, there's something called the spring predictability barrier that makes forecasts much less accurate. Well, not much less accurate, but less confident they would be later in the year. And this is the Northern Hemisphere spring, so finished in May. So we're out of that now. Forecasts can get more confident, but it doesn't just stop as soon as spring ends. As you get closer to autumn, the forecasts generally get more confident. So I think that we shouldn't worry too much about the uncertainty right now. It's quite certain that among the forecasting models, El Niño has started and is continuing. Is the strength, of course, could still be contested, but if it seems like it's going to be at least strong El Niño and above. So I would, in terms of reactions, I would react to that sooner than later. I would consider the El Niño started and growing, and to a strong degree.
That makes sense. Philip, in your presentation, your deck notes noted that El Niño-driven global temperature increases are more likely to affect 2027 than 2026. So how should businesses be thinking about that timing when planning?
I think it really varies between crops. So if you sort of think about if you think about row crops, the impact becomes a little bit more. It becomes a little bit more immediate. So you have the 26 impacts. However, if you sort of think about other crops, or your tree crops, so if you think about your coffee, I think is a great example. Is a lot of the Northern Hemisphere production is already at a stage where the cherries on the trees, so you don't, while you might have a slight negative impact in terms of your yield, it's not going to be critical for this year. But on the other hand, the lack of moisture will have a material impact on what happens to the development of trees and the health of the trees that can produce next year. I think you could draw the same analogy for a lot of other crops. I would throw palm oil into the mix as well, because the impact of weather today is seen 12 to 14 months down the line.
Thank you for that. James, the slides flag several secondary consequences like wildfire, the Panama disruption you were talking about, and reduced river transport. How quickly after El Niño establishes itself do those effects typically begin to materialize?
Yeah, this is an important question. I think there's also a lot of misinformation or assumptions made about when certain weather events can happen, and Philip has done a great job of outlining how this can happen season by season. For these specific events, if we look at things like wildfires and reduced river levels, which I put on the slide specifically, talking about transporting goods down rivers, because it's quite common in the Amazon, in Brazil, to transport grains down the Amazon. And when those levels are low, it can disrupt the supply transport. Things like that, they are caused by more prolonged dry weather, which could start to occur. Yeah, it could start to occur towards the end of the year. I think 2027 in a lot of for a lot of factors, but not all of them, is where you look to for more significant impacts. Things can still happen in 2026, but especially when you consider that it takes time for some things to be impacted, such as tree crops. So that's more of a next year risk, I'd say, or towards the end of this year. When it comes to the Panama Canal, that is an interesting topic. As I said, last El Nino, it significantly disrupted the Panama Canal, and that was now, well, soon to be. It was towards the end of the year, and it was mostly in the next year that the restrictions were really in place. So based on that, you could argue that 2027 is more likely to see more significant disruptions. One extra caveat is that the lake they use to fill the canal is at historically high levels right now. So right now it's more resilient if that drought does occur. And also I think the Panama Canal Authority are keeping quite aware of the situation, possibly more than the previous El Nino. And they've said that they aren't going to introduce any restrictions for the remainder of this year. So they said they have reduced a very small restriction earlier this month as a preventive measure. It's not a mitigative. The El Nino is just getting started. So it's a preventive measure in anticipation of a potential drought. So I think given the resilience of the Panama Canal is prepared for, I think if there is going to be an issue, it'll be more like next year. Again, it depends if they put more draconian prevention methods in anticipation of before the problem happens, then there would be more restrictions, disruption, but we shall see. Was there any other factors? Oh, the storms, hurricanes. That's this year. So the Atlantic season and the Pacific East Coast season and the Pacific West season, that's this year. All those increase in or decrease in storms is this year, roughly July to November period. And then the Australian cyclone season that would be reduced from El Nino would be roughly November to April, I believe. Sorry, that was a long answer, but that's my answer.
That was a great answer. I think we have time for one more. Philip, I'm coming to you for the last one. Southeast Asia and Latin America featured prominently across your presentation. What were the most significant supply chains consequences seen in those regions during previous strong El Nino events?
I think the most pronounced recently would be on palm oil, and the impact that we saw on palm oil production in both Indonesia and Malaysia in 2015-16, which was very clearly the impact of the El Nino. I think if you add to that, I would flag that for other crops like coffee, we sometimes have a positive bounce because of the drier, wet season that I'd highlighted. That's in Indonesia, of course. But just sticking with palm oil for a moment, I think the key point is, given its importance in the overall oilseed complex, it becomes quite dynamic, and not sitting in isolation anymore. So the entire oilseed complex could become quite interesting in that sense.
Well, we'll keep an eye on it then. And unfortunately, we have run out of time. There were a lot of other wonderful questions. Thank you, everyone, for those. If we didn't have time to get to yours, do not worry. We will respond after the webinar, and you will get a response to it. If you found today useful, keep an eye out for other Expana webinars, because we put out these ones all the time. And thank you for joining our El Nino Deep Dive. And thank you, of course, to James and Philip for your time and expertise today. Have a great rest of your week, everyone.